Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another sample problem video in calculus. If you want to anticipate the solution to the exercises here, then you may do so by pausing the video. So here is the first problem. A stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 60 centimeters per second. Express the radius r of the circle as a function of the time t in seconds. Time t is in seconds. If A is the area of the circle as a function of the radius, find A of r, or area as a function of r, and interpret it. And r should be a function of time also. So for part A, r as a function of time equals speed times time. Since the radius is changing at the rate of 60 centimeter per second, 60 centimeters per second, then it's like distance equals speed times time. So radius is the rate of change of the radius, 60 centimeter per second times time. So that's the radius as a function of time. Then the area of a circle, A of r, is A as a function of r, and r is a function of time. So A of r is of t is A of r sub t. But A of r is equal to A of r equals pi r square, and since r is 60t, substitute. So A of r of t is pi times 60t quantity square. So that would be 3600 pi t square. And this is interpreted as area of the circle as a function of time. So that's it for the first part. Then for the second part, uh, for the next problem, an airplane is flying at a speed of 360 miles per hour at an altitude of 1 mile and passes directly over a radar station at time t equals 0. Express the horizontal distance d in miles that the plane has flown as a function of time t. Express the distance s between the plane and the radar station as a function of d. Then use composition to express s as a function of time t. So to help visualize the situation, let's have the figure. So we have a radar station and the plane is 1 mile overhead, and this is the starting point at time t equals 0. The plane will be here at time t hours after. So this distance therefore is speed of the plane times time t, so 360. So that is d, and d is 360 miles per hour times time t. So for part A, d as a function of time is 360 times time t. For part B, express the distance s between the plane and the radar station as a function of d. So this is the distance of the plane from the radar station, that is denoted by s, and by Pythagoras theorem, s is square root of d square plus 1 square, and 1 square is just 1. Since d is 360t, we just call it d because the condition is express s as a function of d. So by Pythagoras theorem, s of d is s as a function of d equals square root of d square plus 1 square, so d square plus 1, square root of d square plus 1. So that's it for part B. For part C, use composition to express s as a function of t. So s of d as function of t is like s of d of t. So we replace d here by 360t. So that would be square root of 360t quantity square plus 1 square. 1 square is still 1. And it is s of d as a function of t is square root of quantity 129,600t square plus 1. So that's it for this problem. Then for the next exercise, if g of x is 2x plus 1 and h of x is 4x squared plus 4x plus 7, find a function f such that f of g equals h. So think about what operation you would have to perform on the formula for g to end up with the formula for h. Since h of x is 3x squared plus 3x plus 2, and g of x is, for part B, if f of x is 3x plus 5 and h of x is 3x squared plus 3x plus 2, find a function g such that f of g is h. For the first part, since f of g is h and this is h, then h of x is something square plus 4x plus 7, then we are sure that f of x is the square of this, since the square of this is 4x squared plus 4x plus 1, and this is 7. Therefore, we suspect, or the answer should be f of x should be x squared plus 6. So that 6 plus 1 is 7. And x square, in x square, we substitute 2x plus 1 square, quantity square, so we have 4x squared plus 4x, which are already these two terms here, plus 1, and it only needs 6 to make it 7 here. So therefore, f of x is x squared plus 6. So to prove that this is really the answer, then let's have f of g of x. F of g of x, which is f of g of x. And it is equal to quantity 2x plus 1 square into this formula, x 2x plus 1 quantity square, then plus 6. Expanding, that would be 4x squared plus 4x plus 1 plus 6. So finally, f of g of x is really 4x squared plus 4x plus 7, and that is equal to h of x. So f of g is equal to h. Then for part B, f is 3x plus 5, h of x is 3x squared plus 3x plus 2. Then we have to find g as a function of x such that f of g is equal to h. So the value of x here to be substituted, because this is x squared, 3x squared plus 3x plus 2, and since there is 3 already here, so we have g of x is x squared, so plus, because there is 3x here, So 3 times quantity, so g of x should be x squared plus x. So that would be 3x squared plus 3x. This is plus 2 and this is plus 5. So we have to, for the constant, minus 1. So that 3 times negative 1 is negative 3, then plus 5 is 2. So g of x is x squared plus x minus 1. So to show that this is really g of x, then substitute into here this value. So f of g of x equals f of g of x. It is equal to 3 times quantity x squared plus x minus 1 plus 5. So simplifying, that would be 3x squared plus 3x minus 3 plus 5. And that would be 3x squared plus 3x plus 2. And that is h of x. Therefore, f of g is equal to h. So that's it for this video. I hope that you were able to understand the explanation and the solutions.